we're going to get into the meat of TypeScript in this video, which is adding types to your application. The basic syntax is to define the type following a colon. Here's an example of such a declaration. You can define a type on a variable, such as const test, and we use string as the type here, and set it equal to test. If we were to have attempted to set it to a number, say 2 for instance, your IDE would give you an error and it would fail to compile. We can also describe what a function returns. So in this case, we're saying const test, which is of type function, is equal to an arrow function, which returns a number type. In this particular function declaration, we are returning the number 5. So this is a valid TypeScript statement. We also can describe parameters of a function. So using that same test const from above, we say that it takes in a parameter, which is called num, and that is of type number. You can see that arrow function also returns a number, and that function itself actually says number plus 2. So this would return, say, 7 if we pass in 5. There are plenty of available types. Number is one. It applies to hex, octal, and binary literals, as well as integer values. So here we have a few of those instances. We also have the type string, which applies to a string as well as template strings. So here you can see where const string is a type string and is equal to the string. And we also have const template string is equal to a template string that outputs. That was a string, in case you were wondering. We also have the function type. So we declare const func is of type function, and then it outputs a console log. You can use that for both arrow functions as well as explicit function declarations. And there's, of course, the type boolean, which in this case we say const true is a boolean that equals true. Next, we have the array type. This represents a collection of items. You can type the array. We can cover that in the generics video later. But here we say const list is of type array. In this case, it'll take any array. We can, again, type that array, but we'll cover that in a later video. The second is giving the list2 variable a array of strings type. So had you put 2 in there, for instance, you would get a compile time error. There's also the tuple type, which is array-like. It's a collection matching a given type order. So here we declared const tup is a tuple of string and number. So it has to be set to a array that contains a string followed by a number. Next we have enum. This is basically a way of enumerating options and abstracting out a given set of values. So in this case we have my enum, which contains 3 options, first, second, and third. You can start the numbering that underneath that represents the value of that enumeration by setting them equal to a integer. So here we say first is equal to 1. In the first example, first is actually 0, second is 1, third is 2, so 0 based. If we say first is equal to 1, second becomes 2, and third becomes 3. Next we have the any type. This is used to describe a variable that doesn't necessarily have a type. So here we say let my var is of type any and my string is of type string. If I set my var equal to my string, it works because it can accept any type. However, if we were to attempt to set my string equal to my var, it does not work because it's of type any and string is more explicit, so therefore it cannot apply without a casting. Next we have type void. This is used only in function declarations. Technically, you can use it for variables, but you can only set them equal to undefined or null, so it's not very useful. That being said, here is a function that returns type void, meaning it does not return anything, it just performs a function. Void is something you should be familiar with from other object-oriented programming languages. There's also null, undefined, and never types. Null and undefined are very similar. They don't really serve a purpose outside of a function return statement, but they can be used. Never is used to imply that a function never returns a value. So if you have an infinite loop, let's say you have a listener for some particular event that's intended to last the lifespan of your JavaScript application, you can use never as the return type of the function. Next, we'll cover type assertions. Type assertions are a lot like casting. Asserting a type makes it behave as if it were that type. So here we say let string is equal to any, or a type any, and the string is set. And then we can say string as string, and then it behaves as though it were a string type instead of any. We can then access the length property of the string prototype. We can also use the less than string greater than in order to cast it as well. Syntactically different, but the behavior is the same. So that was the basic overview of types. You can always contact me on LinkedIn or Twitter. Comment down below. I'm pretty quick to respond. Feel free to subscribe and all that good stuff. I hope you come back for the next video, and I will see you there.